So if this looks a bit familiar, then you probably saw my magnetless wheel lift linear prototype loading test, and this will be the corresponding unloading test. However, if you haven't seen this design before, what this is my attempt to approximate the pocket wheel lift which Martin has specified in his design documents for the Marble Machine XT, the touring version of the Marble Machine. In that, he doesn't want to use any more magnets in the wheels, so instead he wants to use a design of wheel which has just simple slope pockets which will allow marbles to flow in through a tray and then back out on the upper slope. So if you imagine the pocket bottom becomes the pocket top as the wheel turns around, and therefore the unloading angle and the loading angle can be different. In this one, I've attempted to create about a 20-degree angle for unloading because I want this to happen really, really fast. Now, there was some debate on Discord about exactly how wide this tray should be. Obviously, the wider it is, the more curvature you have to deal with, and obviously that's going to be a sort of convex curve at the top, and then you've got to have a concave curve at the bottom where it loads onto the next wheel. So really, to minimise that slope, this tray really wants to be as narrow as possible, but obviously too narrow and the marbles won't have time to get off. So I did a little test earlier on with a 10 centimetre wide tray. As you can see, there were some issues with marbles bouncing in that 10 centimetre tray because they were bunching up as they came off, and one in fact bounced back in, which you don't really want. You don't want marbles bouncing back onto the wheel. There will be a guard of rail obviously going all around the entire wheel, except for obviously the loading and unloading trays to prevent the marbles from falling out in transit. But still, that uses up sort of marble space, and also if you've got marbles pinging about, any one of those could jam somewhere. So I made this one 20 centimetres wide, which seems to be the consensus for in Discord anyway. Let's see how it performs. So that time we didn't seem to have any issues with it bouncing. And just for reference, that took about 1 second to unload 50 marbles, which is easily fast enough for what we'll require. You've got to remember as well that the Martin intends to use 3 different sizes of marble in the Marble Machine XT, so you can give slightly different signs. He wants a slightly smaller marble for use on the vibraphone, because he feels that these sizes of marbles are too heavy. And he wants bigger ones for the drums and smaller ones for the drums as well, to give different effects, you know, like a ghost note or whatever. So this whole wheel is going to be 3 layers of trays at the bottom, 3 layers of trays on the transfer, 3 layers of trays on the exit, and marbles are going to be going from in 3 different concentric rings around those wheels. It's going to be quite complicated. So we need to sort of figure out these baselines before we get to designing it. Now in reality, if you go back to this slow-mo, you can see the marbles actually follow a curved trajectory. So it's more likely that the tray will be more of a curved shape rather than the straight one where everything bounces off the back wall. So a little bit of furious Lego building later, and I've created this sort of curved shaped tray, which I think is more likely what's going to be used on the actual machine. You've still got that 20 centimetre wide entry lane, but it curves and opens out as the marbles spread out, and then obviously they have another long tray here for loading onto the machine. So the 2 wheels will be offset from each other horizontally. Anyway, this one is solid. I've attached that into the tray base. This one actually doesn't attach to anything, but my theory is that nothing's going to hit that at all anyway, so we'll try it out now with some marbles at fast speed, and then we'll try them again at low speed. So that seemed to work really well at high speed. The marbles barely touch the sides of that tray. Obviously there would be a bit of bunching up if there was really a tray edge here and another wheel, but hopefully all the marbles are heading towards the wheel that's turning in the same direction for the next wheel lift. The other thing is, this won't always be operating at that high speed. I mean, that was probably about 1 second to pass for all the marbles, so roughly 50 marbles per second. That's probably the maximum speed this will ever run. Most of the time you're going to be running much slower than that, if you're 100 BPM, something like that for a song. So we'll test it again now at slower speed. I anticipate now this is going to come into play because the marbles won't have quite so much momentum. We'll try it out though. Well, as you saw there, yeah, that came into play there, and it got knocked right off because the it's not really attached to anything. But I think you can see the idea is that would just guide all the marbles down to the bottom, and there's no risk, I think, with this of any marbles bouncing back up into the other wheel. So I think that's as far as I can take this linear prototype. I think some people are going to have a lot of fun trying to CAD these curved surfaces moving from one onto another. That ain't me. So I'm going to leave that to the CADing experts. But I think we've done as much as we can. I think what we've proved is that this loading, unloading mechanism should work. I think 20 centimeters is the right distance. It can work at high speed, at low speed. And I think this angled tray is what most likely going to end up getting used on the actual machine. But we'll see. Tell me what you think in the comments below.